The Research and Development or R&D section of the National Water Supply and Drainage Board NWSDB plays a pivotal role in advancing the organization's vision and mission. By undertaking diverse research projects, we develop practical solutions, enhance efficiency, and create innovative technologies to improve the nation's water supply and sustainability.
R&D section re-established at JRDC premises in 2021. There onward, we got the strategic advantage of being inside a university. The main objective of R&D section is conducting in-house research, collaborative research, and facilitating NWSDB staff to conduct their research activities. And on top of that, we are conducting research symposium annually.
Located at the Joint Research and Demonstration Center, JRDC, within the University of Peradeniya, the R&D section benefits from access to expert knowledge and state-of-the-art research facilities. Our key initiatives include conducting in-house research, collaborative projects, supporting NWSDB researchers, and organizing symposiums to share knowledge and findings. One of our pioneering projects is the production of hydrated lime using calcined dolomite for on-site pH correction. This innovative process has been patented and successfully implemented at the Ruwanwala Water Treatment Plant or WTP, with plans to expand to other treatment plants across Sri Lanka.
Monthly requirement of hydrated lime for NWSDB 420 tons and imports from other countries. So this explores using local dolomite to produce hydrated lime. So this helps NWSDB to reduce import and ensure a steady supply for water treatment. The next step is setting industry standards and optimize production.
The R&D section is also exploring the potential agricultural applications of lime sludge, a byproduct of hydrated lime production. In collaboration with the Horticultural Crop Research and Development Institute or HORDI Gannorua, we are investigating its use as a fertilizer, soil pH corrector, and soil conditioner. Additionally, its potential in skim coat and plaster production for the construction industry is under study.
We conducted this research to determine the effect of application of lime sludge to correct the pH. Actually, we got the positive results from this experiment.
To enhance sustainability and reduce dependence on imported bleaching powder, we have developed an on-site sodium hypochlorite generation system, currently implemented in 4 regional support centers. This system utilizes locally available industrial salt and is being expanded to large-scale plants to replace chlorine gas in water disinfection.
This is the high-strength sodium hypochlorite generation setup. This setup produces sodium hypochlorite using salt water. After produced, it helps to disinfect the water in the water treatment process.
In our effort to improve water quality, we are actively researching methods to reduce manganese levels in treated water. By testing activated carbon and biological trickling filters, we aim to lower manganese levels to 0.02 milligrams per liter, surpassing the SLSI drinking water standard and addressing distribution system concerns.
This is a manganese removing biological trickling filter. It's designed to efficiently removing of manganese level in potable water. In continuous mode, this setup achieves over 90% of manganese removal.
Managing wastewater sludge is a growing challenge in Sri Lanka. To tackle this issue, The R&D section is exploring hydrothermal carbonization or HTC, which transforms sludge into hydrocar and liquid fertilizer. In partnership with the Horticultural Crop Research and Development Institute, HORDI, we are testing these products in agricultural plantations, demonstrating their potential for sustainable waste management.
This is the autoclave reactor we use to convert wastewater sludge into hydrochar and processed water. It is composed with a reaction chamber, a stirrer equipped with a motor and a pressure gauge to indicate pressure. And the temperature and the motor speed is controlled by this control unit.
We are testing the hydrochar for the soil amendment properties, and this trial is conducted, and this is going on.
Premature corrosion of pipes and fittings is a major issue in Sri Lanka's tropical climate. To address this, R&D has developed a graphene oxide zinc oxide epoxy composite, which offers superior barrier protection against corrosion, ensuring the durability of water infrastructure. Innovative graphene oxide-coated natural fiber technology has been developed for removing heavy metals and contaminants from wastewater. Extensive testing has shown that this low-cost sustainable solution significantly enhances the performance of municipal and industrial water treatment systems.
This is an experimental setup to remove manganese and other contaminants in wastewater. We use graphene oxide fiber for this column and this membrane. From this column, we can remove around 96% of manganese, and we currently test these membranes in our laboratory.
Innovation in filtration has led to the development of burned coconut shell or BCS filter media, which reduces backwash water usage while maintaining effective filtration. Initial testing at the Ambatale filter columns has shown promising results, and a pilot project is planned at the Lunuatta WTP RSC UA. Addressing the challenge of water treatment plant sludge disposal, our comprehensive research has explored its use as a construction material, collaborating with the local institutions and industries. We have successfully produced interlock tiles, University of Moratuwa, terracotta tiles, Samagi Industries, roof tiles, Rajakumara Tile Factory, ceramic tiles, Royal Ceramics PLC, cement blocks, ICC, Eco Bricks, National Engineering Research and Development Center. This initiative not only promotes sustainable waste management, but also adds value to construction materials in the industry.
Water treatment sludge has become huge burden to National Water Supply and Drainage Board as well as water industries. For that one, R&D section of the National Water Supply and Drainage Board has done so many experiments and research, collaborative research with various institutions. Finally, we have done collaborative research with NERD, National Engineering Research and Development Center, and produce these eco bricks.
In this journey, we have many achievements: research publications, patent certification, and cost saving by various innovative products.
These successes would not have been possible without the dedication, commitment, and expertise of our officials, researchers, and collaborators. As we continue to innovate and explore new frontiers, NWSDB's R&D section remains committed to advancing research and technology to ensure a sustainable and water-secure future for Sri Lanka. The Sri Lankan cultural heritage is one of the richest and the most colorful in Asia. It is a culture enriched by 4 ethnic groups: the Sinhalese, the Tamils, the Muslims, and the Burghers, by 4 of the main religions: Buddhism, Hinduism, Christianity, and Islam. The island republic lies about 5 degrees north of the equator, and it covers an area of 65,610 square kilometers. The central part of the island is covered by mountains, the highest of which is Pidrutalagala. The land slopes gradually down to the coast, except in the north.
Good morning, ladies and gentlemen, esteemed guests, conference participants. Welcome to the International Water Conference 2025 9th Research Symposium, conduct parallel to World Water Day celebration and the commemoration of the 50th anniversary of the National Water Supply and Drainage Board. It gives us immense pleasure to welcome today's keynote speaker, Dr. Engineer Liyanage, the Project Director of the World Bank-funded Primary Healthcare System Enhancing Project, Engineer D.U. Sumanasekara, the Chairman, National Water Supply and Drainage Board, Engineer T. Bharatidasan, the General Manager, National Water Supply and Drainage Board, additional GMs, DGMs, and all the professionals to this event. We are truly honored by your presence today.
Today is the final and the second day and the final day of the conference. We are gathered here to exchange ideas and open discussion on sustainable water and wastewater management through innovation, research, digitalization, and resilience for future. It is indeed golden opportunity for each of us to enrich and enlighten ourselves. Without further ado, let's dive into our final day promising schedule.
It's my pleasure to introduce our esteemed keynote speaker, Dr. Lalit Liyanage, a renowned expert. He has left an indelible mark in the field of engineering.
Dr. Liyanage is currently working as a project director of the World Bank-funded Primary Healthcare System Enhancing Project under the Ministry of Health and Mass Media. Prior to it, he was the chairman of Ceylon Petroleum Storage Terminals Limited and had worked on numerous projects. He also taught at the University of Moratuwa in Sri Lanka and Northumbria University in the United Kingdom. Dr. Liyanage has obtained his bachelor's and master's degree in electrical engineering from USSR. He has postgraduate diploma in maintenance engineering and management from Indian Institute of Production Management, a computer studies master's degree from University of Essex, UK, and MBA in e-governance from University of Moratuwa, Sri Lanka, and a PhD from the Faculty of Engineering and Environment of Northumbria University in the area of technology-based education.
Ladies and gentlemen, let's give a warm round of applause to Dr. Lalit Liyanage and join me in welcoming Dr. Liyanage to the stage. Over to you, sir.
Very good morning to all the participants in the audience. Very young-looking chairman of Water Board. General manager is supposed to come, I guess, and Mr. Ranatunga and all the other dignitaries in the audience. I met your minister yesterday and a few of the diplomatic delegations as well. So I first of all like to congratulate to the organizing committee and the entire Water Board for organizing such a wonderful conference, international conference. And I am very impressed about the facilities here and the conference. So congratulations once again. It is indeed an honor and privilege to be invited as the keynote speaker today. Big thank you to my friend, your IT manager, Mr. Chintak Abeyvikrama, who has recommended my name, and Mr. Ranatunga and Ms. Darshi for coordinating up until now. When I told one of my friends that I was going to do a keynote at Water Board, he was asking me what I was going to talk. I just joked, I'm going to request them to reduce the water bill. I am one of the lifetime customers of your water supply, and I think we all agree that the current water bill is a bit too high, right? I hope with the current latest budget proposals, it would come down similar to electricity bill. Of course, electricity we can go for solar or whatever, but water, there's no option. Okay, so let's move to the main business. So when I was requested to select a topic for this conference, I went through your conference theme, which is sustainable water and wastewater management through innovation, research, digitalization, and resilience for the future. So I had to be aligned with this conference theme. So I selected 3 words out of that. One is sustainability, sustainable, and then innovation and the future. Hence, my title is A Sustainable Future Through Engineering Innovations. Because I am an engineer, and I assume most of the audience are engineers, or at least with technical or scientific background. Therefore, I guess my keynote would give you some light. And this is the short agenda I would be discussing with you in next probably 45 to 1 hour, 45 minutes to 1 hour. Since my main focus in the talk is sustainability, I will be talking a little bit about sustainable engineering. This is a new area of engineering. And then the water crisis, and then I will be taking you through about 9 engineering fields, engineering areas which have innovations through a sustainable future. This is what great Einstein has told about scientists and engineers. So scientists investigate that which already is, but the engineers create that which has never been. So he has given a lot of credit to engineers. So we have to stand by with what great Einstein said. So what is sustainable engineering? Sustainable engineering is a way of designing and creating things that meet our needs without harming the environment or depleting natural resources. The keywords are environment and natural resources. Today, the world is talking very high about protecting natural resources, protecting water, protecting environment, because we ourselves, people have created a lot of damage to the environment. So we have realized that globally, the environment is getting bad, water is getting depleted. Likewise, so that's why this particular engineering has evolved, in especially, if not in Sri Lanka, Europe, North America, they are highly talking about this sustainable engineering. So what does a sustainable engineer do? We had so far, as you know, electrical, electronic, mechanical, civil, you name, automobile, software, hardware engineers. But what is this new engineering is all about? The primary goal of a sustainable engineer is to design and implement engineering solutions that minimize negative impacts on the environment. The key responsibilities of a sustainable engineer include environmental protection. Obviously, environmental protection. So, design and implement engineering solutions that minimize waste, pollution, and resource usage to have a lower impact on the planet. So, this is the main responsibility. And corporate social responsibility. So, we had CSR in companies. Now, the corporate social responsibility would focus on assist businesses in improving their sustainability performance by implementing sustainable practices and technology. Right? So CSR will have another focus. And then collaboration. So sustainable engineers will have to work with architects, urban planners, policymakers, and other professionals to promote sustainable practices in various engineering and construction projects. Then we have waste management. So we know some incidents happened in Sri Lanka due to bad waste management, Meethotamulla, and similar incidents. So waste management is a critical area of environmental protection. So sustainable engineers will have to focus on develop waste management system to reduce, recycle, and properly dispose of waste generated by industrial processes and communities. And we have sustainable materials. We didn't talk much about sustainable materials in the past. Now there is a focus on sustainable materials. So seek out and utilize environmentally friendly and recyclable materials for construction and engineering projects. So especially civil engineers will have to concentrate on this. And what are the sustainable engineering jobs? So as the effects of climate change have become more apparent, an increasing number of students have pursued their interest in the subject in higher education, with universities around the world increasing the number of sustainability related degrees. I am not sure whether Sri Lankan universities have offered, maybe Professor from Ruhuna University might know. So whether we are offering now sustainability related degrees. So what are the jobs available for the sustainability engineers? One is sustainability consultant. So what they will do? They will assist businesses and organizations in implementing sustainable practices and minimizing their impact on the environment. So they have to, their terms of reference is that they provide guidance and recommendations on how to reduce energy consumption, produce less unnecessary waste, and promote eco-friendly initiatives. Then we have renewable energy engineer, another designation. So what they would do, they specialized in designing and creating renewable energy systems. So we know what are the renewable energy systems. We will talk about it. And environmental engineer, another designation. So they work on various projects related to controlling water and air pollution, managing waste, and repairing environmental damage. So this is what the environmental engineer would do. And we have sustainable transportation engineer. So they focus on sustainable transportation. So they have to work on development of transportation system that prioritize environmental sustainability. We know transport sector contribute much about greenhouse gas emission, right? And then we have sustainable agriculture engineer. So I will talk about agriculture in my next slides, but agriculture industrialization is one of the biggest contributor for especially for the water pollution. So they work on developing practices and technologies that promote sustainable farming. One of the best example is Israel. With only one lake, they supply fruits and vegetables to the entire Europe. They have massively introduced technology into their agriculture, sustainable technologies. And we have energy efficient engineer. So energy efficient engineers work to improve energy efficiency in buildings, manufacturing processes, and transportation systems. So they have to work on all these areas and make sure that they don't violate the environmental damaging rules. So these are the latest job market opportunities for engineers with the global trend shifting towards environmental protection. I hope you have got some idea about this sustainability engineering. So let us move into the main area of my keynote, which is sustainable future. As I said, I will talk about 10 areas of engineering which will have innovations, engineering innovations towards sustainable future. So I will start with water purification and management, then sustainable aviation propulsion, and then clean energy technologies, sustainable mobility and transport solutions, smart cities and sustainable infrastructure, waste management and circular economy, and then agriculture and food security innovations, smart grids and IoT for sustainability, carbon capture, utilization and storage, another concept, CCUS, and finally biotechnology and green technology. So all these 9 engineering areas, the sustainability, will help to protect water. So this is our conference main theme. So we all are working towards protecting water. I hope the selecting those 9 areas will be justified because all will contribute to protect water. Sir Isaac Newton, we all know as engineers, scientists, he once said, "I do not know what I may appear to the world, but to myself, I seem to have been only like a boy playing on the seashore and diverting myself in now and then finding a smoother pebble or a prettier shell than ordinary waltz the great ocean of truth lay all undiscovered before me. Why I quoted this? I added this slide only last night after listening to yesterday's keynote by Professor Asela Patirana, because his knowledge, the wisdom in the water management domain, also the audience before me, you all are water experts. So I consider myself as that small boy when I talk before an audience in the water domain. So please ignore me if I talk something wrong, because I talked to our chairman, our GM. They have worked in this domain for last 30, 35 years. So congratulations. And I saw in the videos yesterday the massive work water engineers, water specialists are doing to give us tap water to our homes. The water crisis. We all know the demand for potable water is outpacing what aquifers and other water reserves has. This is a global phenomena. We all know that. And the UN links water to all 16 of its Sustainable Development Goals. This means the safe water access plays an important role in eradicating a number of major social problems like poverty, gender inequality, and violence. That's why UN has linked everything to water. And then, as per the Natural Resources Defense Council statistics, they say unsafe water kills more people than war and all other forms of violence combined. We cannot imagine, right? But this is the reality, this is the truth. So, diseases like cholera, dysentery, typhoid, and polio are often spread by contaminated water. Therefore, these are the facts. That's why I said there is a crisis, water crisis. So, main reasons for water pollution, I have identified, you may know more than this, 3 main reasons. One is water is the universal solvent, right? So it is very vulnerable to becoming polluted. And then, as I said earlier, industrialization of agriculture. This is a main contributor for water pollution. And then, stormwater runoff. Stormwater runoff takes chemicals in the agriculture industry and gas and oil from the city streets because they don't get absorbed in the soil. So these stormwater runoffs take all these chemicals, gas, oil to the rivers, streams, and water areas. So these are the 3 main reasons for water pollution as per my basic knowledge. And what causes water supply reduction? As I said, water is getting reduced against the population. So population growth, obviously, when the population is growing, because day by day it is growing. We had 6 billion, 7 billion, now it's reaching 8 billion, right? But water is a finite source. And then urbanization. When people move towards urbans, the water board's burden is getting more. Because when people are living in villages, they have well water and rivers and etc. But when people have urbanization, you have more work to do, right? And then climate change, of course. We know in Sri Lanka, we have floods, then we have drought, right? So these are the 3 main causes. I observed as water supply reduction. And what caused the decrease of water quality and quantity? So this is like a chain. Global warming is the main cause, I guess. Due to global warming, we have extreme droughts, massive wildfires, right? In US, it's very common, Australia, and even Sri Lanka, we recently had, I think, upcountry. And then, due to which surface and groundwater disappear, the soil collapses and changes in elevation. And as a result, aquifers and groundwater reserves drying up. And the commercial industries, farming and manufacturing, these are the two other causes because they are the largest consumers of water. So this is like a cycle. So what are the solutions? I have found 3 key solutions for water supply reduction. Number 1 is making potable water from new sources. But how? It is said easier than done, right? How we can do it? Recycling and reusing wastewater, because water is a finite source. So we can only do recycling and reusing wastewater. But there are challenges. To convince people to drink recycled water. Singapore had this problem. They used the membrane-based technology for recycling and reusing. This treatment approach called NE water. NE water, it meets 30% of Singapore's potable water needs. But still, there's 70% left. But still, people didn't kind of initially get convinced to drink recycled water. So what they did, they had a massive PR campaign to make people convinced to drink recycle and reuse water. Even Singaporean officials have been shown drinking NE water to publicize their support for the new technology. So this is the second point, and then reducing the amount of pollutants flowing into rivers and streams, so that our natural water sources will have less polluted. So these are the key solutions I have seen in my literature survey. And there are innovations in water resource engineering. I will not go into, because these things have been extensively discussed yesterday and today and even tomorrow. You know these things better than me. So desalination, wastewater processing, nanotechnology, recycled wastewater, biological water treatment, smart water grid, water resource management, emerging water technologies, and advanced filtration. Desalination, you all know, I don't have to explain. And smart water management system. This is something I think WaterBoard is somewhat there. IoT-based systems, Internet of Things based system that monitor water usage and quality in real time, help identify inefficiency, leakages, and areas where conservation efforts can. And this is the water purification process. I had a bottle here. Yeah. Right. So you all know the water purification process. Let me just file. So let us move into the second area. Which is aviation propulsion. As we know, vehicles have a huge amount of greenhouse gas emission. So you can imagine what is the amount of greenhouse gas emission in the aviation industry with huge engines. So the future of flights, thank you. The future of flights is electric, right, thank you. With integrated propulsion systems that make aviation safer, quieter, and more efficient and greener. There is a need to design and develop a broad range of state-of-the-art solutions across the entire propulsion system, which consists of propulsion, auxiliary power, power generation and power controls, including turbo generators necessary to turn mechanical power into electricity. Power distribution to move high voltages throughout the aircraft and deliver it to electric propulsion units, EPU. The EPU then converts electricity into mechanical power, which turns fans and rotors and allows for propulsion. So this is what propulsion experts, the aviation engineers, aviation experts are working on now. And in today's context, megawatt class turbo generators are in operation. I don't know when Sri Lanka will adopt this, Sri Lankan Airlines, the aircraft, but globally this is happening now. In addition to conventional jet fuel and diesel, this is the gas emission causes, this product is able to run on aviation biofuel or green jet fuel, right, towards sustainability, which is chemically similar to fossil fuel but made from more sustainable alternatives. And as battery technology matures, electric and hybrid electric aircraft can also use a combination of batteries and fuel cells to power the aircraft. The hydrogen fuel cells, green technology, are the latest addition to the growing portfolio of power systems that improve the safety and efficiency of aircraft. The proton exchange membrane fuel cells run up to 3 times longer than equivalent batteries and are 5 times more reliable than small engines. So these are the facts. This is how the aviation industry is working on. They work silently and emit no greenhouse gases, and unlike batteries that need to be recharged, hydrogen fuel cells can be refueled in seconds. So there are pros and cons, advantages, disadvantages, but end of the day we have to see what is best for the industry. And there are 3 options, like in the motor industry, car industry. So all electric aircraft, hybrid electric aircraft, and hydrogen or electric fuel cells. So these are the options the aviation engineers or aviation experts are working on. So in all electric aircraft, due to the range limitation with battery-powered electric propulsion and various challenges with hydrogen-powered aircraft, environmentally friendly short-range commuter aircraft are likely to be first types of sustainable civil aircraft to enter into service. So it will be a gradual process. And hybrid, for the replacement of medium-range aircraft such as A320 and Boeing 737, it is likely that hybrid electric aircraft propulsion will come first, followed by hydrogen-powered turbofans for the replacement of long-range aircraft. So, as I said, it's a gradual process, but in near future we will see the gradual reduction of greenhouse gas emission in the aviation industry. And then hydrogen electric fuel cells, as I think discussed about hydrogen fuel cells in the previous slide. So this is how the aviation industry will apply technologies, the innovative solutions to make sure that aviation industry is sustainable and environmental friendly. And now we are moving to the third area, which is clean energy. We know about solar power. We have a lot of information about solar power and wind energy and energy storage solutions, because that's another area where we don't get solar power. In the nights, we don't get wind power all the time, so we have to have storage solutions. And then hydrogen energy, which is pure green energy. So these are the technologies, and these technologies powering clean energy transition, smart grids. So let me just explain what is smart grid. You all know electricity transmission and distribution networks upgraded with digital technology to better manage the flow of electricity from generation to consumption. So everything is managed by technology, smart grids, AI, machine learning. We know the recent Panadura substation incident where we had a blackout. So their explanation was, CB's explanation was, on Sundays they let domestic solar generation to come to the grid as much as possible, but they don't have much control when domestic solar generation comes to the grid on Sundays. So this happened on a Sunday. But if we had a smart grid, this wouldn't have happened. So minister wouldn't have to tell monkey stories then. Batteries, I talked about batteries. And electric vehicles, we all know electric vehicles. And green hydrogen and green buildings is another technology, another concept. So we have building and construction sectors emit about 38% of global greenhouse gas emission. Around 35% of total energy consumption also comes from these sectors, the construction. They are highly energy efficient, having constructed using sustainable materials, such as green steel, hence highly water efficient, and they factor in proper waste management. And then electric cooking. In Asia Pacific, about 1.2 billion people lacked access to clean cooking facilities in 2020. And they still cook with biomass, charcoal, and kerosene, and are exposed to dangerous levels of indoor air pollution. So we need to really think about this. And the other area is sustainable mobility and transport solution. So electric vehicles, obviously, and under electric vehicles we have battery technology and wireless EV charging. So this is another area. Research into inductive or wireless charging systems could eliminate the need for physical connections and reducing wear on charging ports and making charging more accessible. And then smart charging networks. The development of smart charging system which optimize when and how EVs are charged based on grid demand can enhance the integration of EVs into power grids and reduce overall energy consumption. Smart charging. And then public transport electrification. I will cover this area in my previous slide. So sustainable transport solutions. So encourage more carpooling and ride sharing. I think we had this discussion sometimes back. Carpooling and cars cannot come only one passenger. They have to get other passengers also when it comes to Colombo kind of thing. So these things are happening in other parts of the world because this can significantly reduce greenhouse gas emissions and traffic, etc. Then supply chain transportation. Greener supply chain transportation, this is very important because 8% of global greenhouse gas emissions happen in this area. And the education of drivers on more sustainable travel. This is another area. As a government, we have to educate drivers as to how economically drive. And some popular commercial green transport solutions. Number one, electric vehicles and electric vehicle infrastructure. We all know Elon Musk, his Tesla network. So he has kind of dominated electric vehicle manufacturing. Not only that, he has a supercharger network which has enabled more than 10 billion electric miles of driving, potentially saving over 4 million tons of carbon dioxide emissions compared to equivalent travel in petrol-powered vehicles. And we have smart mobility solutions by Mercedes-Benz. This is intelligent world drive. So it has developed the intelligent world drive and advanced driver assistance system that uses artificial intelligence and connected vehicle technology to optimize traffic flow and reduce emissions. And we have urban planning, London's ultra-low emission zone. So this is to improve air quality and reduce carbon emissions in the city center. Vehicles that don't meet strict emission standards must pay a daily charge to enter the zone. This is how London has done. On an average day, 96% of vehicles driving in London now meet the standard. And then we have sustainable fuel for cargo transport, Maersk Eco Delivery. So they have introduced this sustainable biofuel to power vessels. By doing that, it has also ordered 19 carbon neutral container vessels powered by green methanol. So there are many initiatives by world leading companies. And then efficient logistics by UPS Orient. So they have this advanced route optimization system which manages again by artificial intelligence and machine learning. So the route management is efficiently managed. And then we have hydrogen fuel, Iberdrola green hydrogen. So we know what is hydrogen fuel and it is a green fuel. And then we have biofuels by Shell Aviation Sustainable. This is for aviation industry, biofuel. And then we have public transport again, London zero emission bus fleet. So Transport for London is transitioning its entire bus fleet to zero emission vehicles like electric or hybrid vehicles by 2034, where more than 800 zero emission buses have already been introduced. And synthetic fuel, Porsche car company has introduced e-fuel. And then cycling infrastructure. So we have seen even prime ministers, presidents go on bicycles in other countries. So this is the best way for personal health as well as for the environment. So they have spent a lot of money on bicycle route infrastructure and bicycles and bicycle parks, etc. So these are the popular commercial thing, and I will go into the next area, that is smart cities and sustainable infrastructure. So you can see in the picture what is needed for a smart city. So various components should contribute: a smart government, smart healthcare, smart transportation, smart water management, renewable energy, smart agriculture, smart waste management, smart connectivity, and smart home. So this is what explained here, smart building and sustainable construction, innovations like green building material, I talked about it, 3D printing building. So construction industry is using now 3D printing building, which saves a lot of resources. And then that is design and modular construction technologies, and smart grids and IoT in energy management, right? Smart grids, IoT-enabled devices, and data analytics, right? So these are the things which will contribute to smart city technology. And positive examples of smart and sustainable cities. There are 3 cities I have found. One is smart city Zurich. Zurich started this journey in 2018 with improvements include infrastructure which has been digitized, public transportation, and a smart building management system to regulate energy consumption. Now it is a complete smart city. And then we have smart city Amsterdam. They embarked on this smart city journey in 2009, long ago, to minimize 40% of carbon emissions by 2025 this year. So they have achieved it now. And so both above cities want to implement technologies to improve the quality of life of their citizens. So end result objective is to improve quality of life of citizens. And then we have smart city Songdon, South Korea. We all know South Korea is #1 in the world e-governance index, e-management index. So South Korea is one of the best countries in the world. So they have this smart city. They started the project in 2003, again, promising smart infrastructure, but also ecological aspect. So these are some of the examples from the world. And the other area is waste management and circular economy. So what is circular economy? In a circular economy, production materials are designed to be reused, recycled, recovered, or remade to keep them in the economy for as long as possible. Waste is avoided or minimized, greenhouse gas emissions are cut as a result, along with unsustainable use of the planet's resources. So this is what green economy is. And waste to energy technologies. Now even in Sri Lanka there are plants. They collect all the waste and they recycle and they even generate electricity. One is there in Vattala area. And then recycling and upcycling innovations. We know how it happens. And circular manufacturing. Engineering approaches focused on circularity, designing products for reuse, remanufacturing, and repair are reducing. And then circular economy in construction. And then waste management and circular economy. You can see the 2020, 2030, 2040, and 2050. So projections of global municipal solid waste generation per year in 2030, 40, 50 if urgent action is not taken. So if government will not take any action, this will happen, wastewater management. But you can see here. So, globally, governments are working on this. So they have worked on recycle. So you can see they have increased the recycle thing. Waste to energy, landfill, and uncontrolled. So you can see uncontrolled comes to 0. So world has done a lot of things on this area, and you can see a decrease in circular economy projection. Right? This is a good news. So we all as citizens should contribute towards this. So domestically we can use 3 bins and, contribute. And this is the heat case for a circular economy in waste. The picture says everything, how it happens, how the waste goes to the natural water resources, and waste management and circular economy. You can again see 2020 and 2050 waste management as usual, but 2050 waste under control and 2050 circular economy. So you can see the improvement. If we apply circular economy and waste management concepts rightly, so we can achieve good results. So this is a message for the government. And innovations in agriculture and food security, another area. Vertical farming, we all know, traditional agriculture is often limited by space, climate, and resources. Vertical farming offers a game-changing solution by cultivating crops in stacked layers within controlled environments such as urban skyscrapers or climate controlled areas. So in the urban areas, this is the best way to do. And then precision agriculture, data-driven farming. This is what I said in Israel happening. So they collect all data using IoT sensors, drones, etc., and they apply that. And then aquaponics, the harmony of fish and plants, and 3D printed food, a futuristic feast. So that is plant-based and lab-grown meat. So these are the new things happening. So even you can print your food at home using 3D printing, inserting right material to the 3D printer. Even I recently listened to a presentation, even your body organs can be printed using 3D printing and used in surgery, because you might need a kidney for your transplant, but it's difficult to find. So using 3D printing, latest technology, you get a kidney printed by a 3D printer. Difficult to imagine, right? How the technology goes. And then plant-based and lab-grown meat, bugs on the menu. That is insect farming. Insects such as crickets and mealworms are highly nutritious, require minimal space and resources, and produce fewer greenhouse gas emissions compared to conventional livestock. And then smart storage solutions, prolonging freshness. If you have smart storage solutions, and then climate resilient crops adapting to change, and mobile apps for food redistribution, fighting food waste, and blockchain for transparent supply chains, blockchain technology. So these are the things being used in agriculture and food security. You can see this picture says everything. Increase crop productivity, conserve biodiversity, provide a better environment, reduce carbon dioxide emissions, save 23 billion kilograms of carbon dioxide equivalent to removing 15.3 million cars off the road for 1 year. So these are the facts. And help alleviate poverty and hunger. Biotech crops uplifted the lives of 17 million farmers and their families, totaling 65 million people. So these are the global facts. And positive impact of technology, IoT, remote sensors, crop nutrient management, autonomous farming, and precision agriculture. Predictive data analytics in agriculture, geographic information, GIS in agriculture, bioengineering in today's agriculture. And then smart grids and IoT for sustainability. I talked about smart grids, electricity. Board is, I think, working on, they are working on smart meters, IoT based. So this will happen, I guess, soon. And these are the components of IoT in smart grids: smart meters, sensors, communication network, advanced analytics, and grid automation. Then IoT applications in smart energy, demand response programs, energy consumption monitoring, so likewise. And these are the benefits of IoT in smart grids, the challenges in implementing IoT in smart grids. Then the other area is carbon capture, utilization, and storage, CCUS. This is another concept. So we know we need oxygen to live. We don't need carbon dioxide. Now there are technologies to capture carbon dioxide and get under the earth and storage. So these are the sources which emit carbon dioxide. So they capture, compress, transport, and where you need utilization and storage. So this is how it goes to underground, carbon dioxide capture, and they store it deep under the earth. And finally, biotechnology and green chemistry. Biodegradable plastics is one of the options. So bioplastics made from renewable resources such as cornstarch and algae are being developed to replace traditional petroleum-based plastics and reduce pollution. And synthetic biology for environmental remediation. So this is again another area of sustainability. This is the graphical abstract of biomass production. So I want to show this video to capture all what I talked about, because it might have been boring when I talk, but this video will capture everything you want to see. Can we play it, please?
Here are the 10 most futuristic places in the world that you won't believe exist. Number 10, Songdo, South Korea. Songdo is one of the world's first fully smart cities. Here are the 10 most futuristic places in the world that you won't believe exist. Number 10, Songdo, South Korea. Songdo is one of the world's first fully smart cities, where nearly everything is connected via the Internet of Things. From garbage disposal to traffic management, the city operates using high-tech automation, making it a model for future urban planning. Songdo's trash system is entirely automated, with waste traveling through underground pneumatic tubes to processing facilities. Number 9, Changi Airport, Singapore. Changi Airport is more than just a transportation hub. It's a futuristic destination featuring the world's tallest indoor waterfall, robot cleaners, and a butterfly garden. It seamlessly integrates nature with technology, making it a model for the airports of tomorrow. The airport is also home to a giant netted playground, complete with slides, suspended bridges, and an air-conditioned forest. Number 8, Masdar City, United Arab Emirates. Masdar City is the UAE's carbon-neutral, fully sustainable city designed to have zero emissions. It's powered by solar energy and features electric driverless cars for public transportation. But despite its futuristic ambitions, the city still struggles to attract permanent residents due to its desert location and extreme climate. Number 7, the Eden Project, the United Kingdom. This vast eco-project in Cornwall, the UK, features enormous biomes that simulate different ecosystems from around the world. It's an example of futuristic sustainability efforts, showing how human-engineered environments can mimic natural ecosystems. One of the biomes houses the largest indoor rainforest in the world. Number 6, Neom, Saudi Arabia. Neom is a planned futuristic city in Saudi Arabia designed to be powered entirely by renewable energy. It's expected to include flying taxis, an artificial moon, and a glow-in-the-dark beach. One section, called The Line, will be a 170-kilometer linear city with no cars, no streets, and run entirely on AI. Number 5, the Mars Science City, United Arab Emirates. The UAE is building a $140 million Martian city simulation in the desert to test the possibility of life on Mars. The city will replicate Martian living conditions, providing a research base for scientists and engineers. The project includes a museum built from 3D printed sand from the Emirati desert. Number 4, Shenzhen, China. Shenzhen is known as the Silicon Valley of hardware and is pioneering advancements in drone technology, AI, and 5G networks. The city is filled with towering futuristic skyscrapers and smart technology integrated into everyday infrastructure. Shenzhen is home to the world's largest drone manufacturer, DJI, which produces 70% of the world's consumer drones. Number 3, the Hyperloop Test Track, Nevada, USA. The Hyperloop is Elon Musk's vision of the future of transportation, with passenger pods that can travel at speeds over 700 miles per hour in vacuum tubes. The test track in Nevada is the most advanced prototype of this potentially revolutionary system. If fully realized, a Hyperloop trip from Los Angeles to San Francisco could take only 35 minutes. Number 2, Singapore's Supertree Grove, Singapore. Singapore's Supertree Grove is an eco-park featuring massive artificial trees that are covered in plants and provide shade, generate solar power, and collect rainwater. These futuristic structures help cool the surrounding environment while blending nature with technology. Some of the super trees also light up in a synchronized evening show, powered by renewable energy. Number 1, Oslo Airport City, Norway. Oslo Airport City, currently in development, will be the world's first fully sustainable, self-sufficient city powered entirely by renewable energy. This futuristic city will feature autonomous vehicles, green rooftops, and energy-positive buildings.
Right. I think I am up with my time. Can I use 5 more minutes? Yeah, okay. Right, there are some scary data about environmental factors. I will just quickly go through. Earth's temperature has risen by an average of 0.14 Fahrenheit per decade since 1880, or about 2 degrees Fahrenheit in total. So these things, I think my slides will be shared so you can get this scary data. Greenhouse gas emissions from on-site direct emissions in homes and businesses have increased by 2% since 1990. And the burden of disease attributable to the environment amounts to 13 million deaths each year, 1/4 of all deaths. The global smart cities market size was valued at roughly this billion in 21 and is expected to peak at almost $1 billion by 2032, registering a CAGR of 13.9% according to the latest study published by Emergency Research. And likewise, there are many scary data about our global environment, global greenhouse emissions, etc. So we as citizens have to be very careful, and also, and this is the slide I wanted to show our neighbor, India. So we as Sri Lankan engineers, we have to really think. We know our cream of our engineers are working in NASA and other places, but as an engineering industry, where Sri Lanka is, because we are coming from India, our roots are from India, and they have gone to moon and they are exploring sun. So just wanted to give you motivation. Our cream of engineers have to work on this. And my conclusion is call to action. With that, I will encourage the engineering community, not only engineering, scientific and technical, here to continue driving innovation, collaboration, and sustainable practices. And I do emphasize the need for engineers to think beyond technology and embrace holistic solutions that integrate social, environmental, and economic sustainability. And inspiration, I want to assure you all that in the future, engineering shall lead to a cleaner, greener, and more equitable world with India as a key player in that transformation, because we have to take example from India. The engineering innovations that I presented are not only reshaping industries, but also playing a critical role in mitigating the impacts of climate change, improving resource efficiency, and creating a more sustainable and resilient global economy. Finally, engineering fact: long time ago, people who sacrificed their sleep, family, food, laughter, and other joys of life were called saints. Now they are called engineers. Let me congratulate once again all the paper presenters, the poster presenters of this conference, and you all are doing a good job. I can remember one of the water board engineers used to present when I was the chairman of Institute of Engineering and Technology, Aravinda. He is no more in the water board, so I was encouraging him, being in the government sector, public sector organization. And after 2 years, we elevated him as the third place winner. So once again, I thank Chairman, GM, Mr. Ranatunga, and all the organizing committee for making this wonderful conference. Thanks for inviting me once again. Thank you very much.
Thank you, Dr. Lalit Liyanage, for that insightful speech. We are truly grateful for sharing your valuable thoughts. Knowledge is power, as Foucault says, so we can do some changes in the world if you well versed with the knowledge. Let's give another applause to Dr. Liyanage, ladies and gentlemen.
To present the token of appreciation, I kindly invite Chairman, National Water Supply and Drainage Board, Engineer D.U. Sumanasekara, Additional GM, PNP, and the co-chair of IWC 2025, Engineer N.U.K. Ranatunga, on stage. And also kindly invite Dr. Liyanage to accept the token of appreciation.
Ladies and gentlemen, this brings us to the end of our program. We can have our refreshments now. Those who have not taken your refreshments, you can go and have your refreshments. And others, please proceed to your conference halls. And also we have an exhibition on the first floor, and oral and business forum, so you can proceed with these sessions. Thank you so much.
Also, please note that we have the R&D technical session 7 at 11 a.m. here at the auditorium, and the session 9 at Hall G, session 8 at the Hall H. Also, there's a special session by MS Hexing Electrical Company Limited at Hall E. And after the lunch, again, technical session 10 at the auditorium, technical session 12 at the Hall G, and the technical session 11 at Hall H. Thank you.
The Sri Lankan cultural heritage is one of the richest and the most colorful in Asia.